Today we're going to talk about a family of quadrilaterals. So we're going to look at special parallelograms. Many quadrilaterals share some of the same properties, so we can kind of look at this as in a diagram. At the top we have our parallelogram, and we know our parallelogram has specific properties. Opposite sides are congruent and parallel, opposite angles are congruent, and the diagonals bisect each other. But under parallelograms we have two different types. We could have a rhombus, and a rhombus, the property that makes a rhombus is that the fact that it's a parallelogram with all four sides congruent. So it has all the properties of the parallelogram plus the fact that all four sides are congruent. So that's a rhombus. That should be an R right there. And then we also have a rectangle. So the rectangle is also a parallelogram, but it has the property that it has at least one right angle. And it has all the other properties of the parallelogram. And then finally we have the square. And the square is both a rectangle and a rhombus because all four sides are congruent and it has a right angle. So the way you look at this diagram, the square has all the properties of everything above it. The rectangle has the properties of parallelogram, and the rhombus has the properties of a parallelogram. But not every rectangle is a rhombus, and not every rhombus is a rectangle. But every square is a rectangle and a rhombus. So based on that information, you can go through and decide whether these statements are true or not. All rectangles are parallelograms, all parallelograms are rectangles, all squares are rectangles, all rectangles are squares. And we will talk about that in class. If a statement is false, you should explain why. So we're going to do a couple of proofs using the properties, the main property of rectangles and the main property of a rhombus. And the first one says, if a parallelogram is a rectangle, then the diagonals are equal in length. So here's my rectangle, A, B, C, D. Remember, we label around the rectangle. And it's a rectangle because it's a parallelogram with one right angle, or they're equal angular, and so I say one right angle, but once I have one, they're all going to be right angles. And we want to show that the diagonals are going to be equal or congruent to each other. So to do this type of proof, I'm actually going to break these overlapping triangles out so I can look at them. I really have triangle ABD, and I have triangle CBD, or BAC, or however you want to say it, CBD, I guess. DAB and CBA. CBA. Okay. If I look at that, I can use the rectangle properties to say that those two angles are going to be congruent because rectangles are equiangular. And I also know that opposite sides of a rectangle are congruent, and then AB is shared by both of these triangles, and AB is reflexive. So that's how I'm going to go about solving the triangles congruent, and then I can go back and use CPCTC to say those two other sides are congruent. So let's take care of reflexive. AB is congruent to AB, and that's the reflexive property. Okay, now I can say that angle CBA is congruent to angle DAB because rectangles are equiangular. When I'm doing these types of proofs, I can use every other property except the one I'm trying to prove. So that makes it easy. You have a lot of choices. Rectangles are equiangular. Okay? So now I have the angles congruent. We also know that opposite sides of a rectangle are congruent. So DA is congruent to CB. In a rectangle, opposite sides are congruent. That's enough to say, because I have side angle side, I can say these two triangles are congruent. Once I have that, then I can say the diagonals are congruent to each other by CPCTC. So, step 5 is triangle DAB is congruent to triangle CBA, and that's side angle side. Finally, I can say that AC is congruent to DB because corresponding parts of congruent triangles are congruent. So now we've proven that the diagonals are going to be equal. So a property of a rectangle is the fact that its diagonals are equal in length. That is not necessarily true of every parallelogram, but it is true of a rectangle because we just proved it. So the second proof is going to be for a rhombus, and we want to show that the diagonals in a rhombus are perpendicular. So this is going to take a few steps, and actually I'm probably going to have to scroll down to add all of the steps. But we have our rhombus here, and we want to show that AC is perpendicular to DB. Well, here's how you show that things are perpendicular. What you have to do is get two angles that are consecutive to each other, right next to each other, to be congruent. Because if two angles form a linear pair and they are congruent, they have to be 90 degrees. So for this rhombus, I'm going to look at getting consecutive triangles congruent, if I can do that. And, well, here's kind of our process. We know if I look at the top two triangles, if I label the center E, then EC is going to be reflexive, so there's a side. I know that I have these sides because a rhombus has all sides the same. And then I have to try to get something else. So if I look, I should be able to get the angles because in a rhombus. Okay, the third thing I'm going to get is the other side. I had to think about that for a minute. Because we can use the parallelogram properties that the diagonals bisect each other. So this is what we're going to end up with, and then we can use side, side, side. So here's how we get started. Let's start with the reflexive. We can say EC is congruent to EC. We always like to start with the easy stuff. There's some easy points for you. Reflexive. Okay. We know that DC has to be congruent to BC because rhombuses are equilateral, meaning all sides are the same length. Rhombuses, rhombi, I don't know, rhombuses. In a rhombus, let's just say in a rhombus, sides are equilateral. In a rhombus, maybe it's rhombi, I don't know. Sides are equilateral. Okay, and then I can get DE is congruent to DE because in a parallelogram the diagonals bisect each other. The diags bisect each other. All right, so now that's enough to say that the triangles are congruent. Triangle DEC is congruent to triangle BEC. This time I've used side, side, side. And then I can say that angle DEC is congruent to angle, not triangle, but angle BEC. Because corresponding parts of congruent triangles are congruent. Since they are equal and they are a linear pair, we can now say that DB or AC is perpendicular to DB. AC is perpendicular to DB because angle DEC and angle BEC are right angles. Something like that. So that's how you show that now we have this property that the diagonals of a rhombus are perpendicular. So we can use that in further proofs when we need to. So we'll practice more of this when we are together in class.